Morning. Myself P. Balakrishna from EC Department in Ramchandra Engineering College. So yesterday we can discussion QPSK and how to define QPSK, how to can convert some information from source to destination, some transmit and receiver side. We simply are using some binary information. All are we can discussion yesterday. So now can explain today DPSK. So this is simply a differential phase shift keying modulation. That is means simply to modulated signal, simply to modulated the input signal that is shifted to related to the previous signals elements. That is with the help of some carrier signals. So here also same thing, nearly are equal to the QPSK or equal to DPSK. Here also to simply to identify the input binary numbers, that is 0, 0 and 1, 1. Do some example. Here also simply to change the phase. Here we can define DPSK is a continuous pulse of the any two input binary digits. That is that means is a differential of the two input digits. And also one more here, you can observe that the phase will be simply to change. So here QPSK here simply to change the phase in nearly is stability condition is 0 level, but here the phase will be changing. We can move next stage. We can change the next stage. That will become change easily to the phase. And here also be seen if the data bit is low and the phase of the signal is not reversed, but is contained as it was with the data high. Nothing but high and low value. We are usually to simply to non-returnable 0 of the differential amplifier. And here also same can explain how to high and low values. You can define that input. Here also you can find out that word binary expect of 2 bits, that is M, simply represented a digital that corresponding to the number of conditions. So, and one more thing is the levels are combination process possible for a given number of binary variables. This type of digital modulus technique is for data transmission in which instead of one bit, 1 or 2 bits or more bits are transmitted at a time. A signal is used for multiple bit transmission. The channel bandwidth is reduced. That means simply we are using the multiplexing operation. So the number of channels are increased, automatically the bandwidth will be slowly reduced. And we can explain how to convert it, how to transmit differential binary phase shift keying modulation. We can simply, here you can observe that one block diagram is there. So simply the block diagram is how to deliver information. We are using XOR gate, simply the off bit delay of the input bit. We are using to recurring of clock signal. So always the clock signal with the help of the input message signal, you can use it to deliver the output. And one more thing here, the input data, and you can observe the delay of the data and record of clock signal. That is, you can define every input binary digits you can generate at one clock period. That means here observe that. And one more thing, clock recovery circuits is delay inputs. We are using XOR gate, and same thing it is a balancing modulator also. And you can simply to display the differential binary phase shift key modulus. That means simply the phase will be changed compared to the previous and next stage. And one more thing here, you can observe that how to change and how to move the binary interface and how to change the phase. Here mainly thing is 0 to up to 270 degrees will be changing the frequency, change in the phase. Here you can observe that simply the 180 degrees and 0 degrees, and another continuous is based on is the input binary data. So here the input binary data is a 0, 1, 1, 1, 0, something is a different input binary data. That data will be basically to simply the delay of the clock pulse. And continuation, how to receive the input data at receiver side is a DPSK, that is the DPSK, differential binary phase shift keying. So how to receive the signal? Here also an example, the block diagram here. So this block diagram is simply to DPSK input. You are using balancing modulator. This is very important. So here using balancing modulator can easily to recover the input data, and also here using the delay of the time. That means you can using some clock pulse also here, so simply to deliver the information. And one more thing is the balance modulator are simply working with the Q factors and I product of the signals. We can observe that simply the formulas of the balance modulator output. And one more thing here, how to shift the phase. Here you can observe that at 180 degrees are shifted 180 degrees, that is means 1 this is the reference phase of the DPSK input, and remaining all things you can observe that simply to move left to right, right to left, here can simply to design of the binary bits. Thank you one all. Remaining topic we can discuss in tomorrow.